Okay, so yeah, last time there was an issue with how we save the mesh, and we're gonna do it really quickly, really different. So first we delete this. We go here, import Fluent case, browse. You go to your Airfoil files page, db0, ICM, ICM CFD, change this to Fluent mesh file, and it's this one. You can save it. Let's go to setup. Okay, it's okay. Double precision again. So we have to do this thing again. Changing the boundaries, so separate faces, region, the boundary, separate, and we're gonna have the airfoil and the inlet. Okay, let's see which one is which. Inlet. Display, so it's the first one. We want again angle 88. Okay, let's see which one is this one. Outlet, type, pressure outlet. Oh no, sorry. Pressure outlet. Let's change it to outlet, the name. Can already put this at 0.05 and 5. Apply. Close. Type. Oops. Let's see which one is it first. Airfoil. So type wall. Okay, airfoil. Apply. Close. This should be the velocity inlet. Yeah, just change the name to inlet. I'm gonna change this already. Okay, we have now our mesh well defined, and we're gonna save it. Hopefully we don't have the same mistake. Check here. It's not perfect yet, because we didn't set up everything yet. Let's model. Energy on. Let's go here and put the viscosity on. Then what else? Materials. So we're gonna change the density 1328, and this is just to give a Reynolds number of 6 million. That's the case we're using. Inlet. Magnitude direction, velocity 68. X flow. So 6.5 cosine. Okay, that value there, 0.9935. 57. Okay, and the y, we just go here and the same, but sine 11.320. 11.32.0. Okay. Thermal. It's minus 4 degrees Celsius, which means 269.15 kelvins. Outlet. Let's just put the same temperature. Close. Airfoil wall. Thermal. Temperature. Let's put 281 kelvins because this is the adiabatic temperature plus 10 degrees as recommended by the guide, ANSYS guide. Materials and just reference values. Inlet. Okay, that's okay. The area is not 1, but it's rather 0.05 because we use the 0.05 meters for this, for the width. If we check performance check, yeah, 0.05, so 0.05 times 1 gives us the area. Methods coupled, yeah, pseudo transient. Let's create some reports for lift and drag. Lift coefficient, airfoil. No, here you can do the little drawing and you see that it's going to be equal to minus 0.11 to the x 1132, so that, and this is going to be the other one which I don't have anymore, so that is cosine and 99357, 0.99357. Just going to write this. Okay, 1 report plot, pretty cancel, and we're going to call it CL. Now 1 for drag, for CD, here is on the Y, actually on the X is 0.93571, and the Y is again 0.5 sinus 0.113203 plot console. Okay, let's check again the CL. Yeah, so minus the X and plus the Y. Yeah, if you do a drawing you can see this correct. Close. Let's change the monitors, all of them to this one. That's one let's see what I use. Okay. And we can save. Let's initialize first. Standard from inlet initialize. Taking a bit of a time. I don't know why. Okay, that's it. File, save. Saving. Still thinking. Okay, it's saved. So that is question mark and I don't know why, but read that. Okay, let's close. Let's can refresh solution. Okay, I think we can start it. Let's initialize it again. And let's run. First, just one iteration. Okay, that was good. Let's run it for more. Okay, this is what we wanted, so that's cool. 200. And this depends on your okay, sorry for the mess that was here, but I really wanted these 2 ticks to be there. Now it's on because it's thinking. And so we need to go straight into solution. So we need setup and then solution. And then it is okay. And the second thing is, remember to cut this link and instead save here and then go to setup and load it separately. So now it's running smoothly. And we're going to look at the CD and CL pots and also the residuals to see when we should stop it. It should be when all these values are below 10 to the minus 6. It shouldn't take too long, depending on your computer. Okay, so we have finished. We can see that both the drag and the lift are in reasonable values. So a lift coefficient of 1 is what we expect. And a drag coefficient close to 0 is also what we expect. So there it is, that's 0.016. Yeah, that's okay. Residuals are all below 6, so that's okay. Let's check. Yeah, that's perfect. So let's save project. Done, so we can close this. Yeah, I think it's gonna save again. Yeah, it's okay. Okay, now we're here on our project. Save again because yes. So now this mistake can go back, and then we drag solution into Airflow. Refresh. Okay. Let's update. We can go into. I think first we need to update the Airflow. Wait. No. Okay, update. It's importing the file. No, that's good. Now let's set up our droplets. It's weird. Let's see. No. Exit seems okay. What's the matter with it? New solution. Yeah, let's move on and see what we get. So droplets, water. Select this. Conditions. Velocity. Okay, the Reynolds is not exactly. This is more or less what we wanted. Mach number, adiabatic ignition temperature. You see that's why I put 281. Now let's use 0.25 here. 20 microns. The mono disperse. Yeah. Boundaries inlets. The inlet. Space absolute import reference conditions. Supersonic far field. And here. The wall. Okay. Symmetry. Solver. Out. Okay. It's cool. Cancel. Save first. Close. Solution. use 4, that's okay. And let's update. Local log. This is a bit weird, but let's see. That's the problem. And it's going to take a bit of a time. We'll wait again. Okay, now I'm going to stop to see if it's good. So load stop. We'll stop. Stop. Okay. It's thinking. Log. Okay. Now let's see the solution. Okay, that's good. Good enough. Oops. I really recommend using a mouse for this. Yeah, that's good enough. I don't have the pen because I'm not using a proper mouse, but you can see that that's okay. Let's keep on with this. Set up ICE. This should be really fast now. Set up ICE. Let's put activated with beating. Reference output. Okay, to fix. Okay. Conditions. It's all the same again. And change this. Wall. And it is. Icing just enabled. Condition. Okay. Symmetry. Outlet. Inlet. Okay. Total time. Let's do 10 seconds for now. Yeah. Out. Yep. Okay. Save. Close. Solutionize. CPU is 4. I can also edit these things here. And properties. Okay, 10 seconds. Yeah, let's run it. Update. See, we're going to be really fast. Okay, it's done. Let's see the solution. View solution. Okay, it caught the ice on the leading edge. That's what we were expecting. Let's view ice. View ice. There it is, just a bit on the front. Very little, just a bit. You can go to query and do a 2D plot. Plane Z, sorry, Z, exactly. And geometry. No. No. Okay, Okay, I don't know why it's like this, but okay, this is what I want. No, I wanted to zoom in there. It's a bit difficult with well, I see it there at the front, just 10 seconds, so that's why it's only this. Okay, now let's displace the grid, update. For some reason it didn't move on, update. Update again. Okay, so that's it. Let's save the project. And we have the ice. Now there's another thing I want to do is do a multi-shot sequence, and for that we're gonna pick the results from this and put Fluent again to see how much of the performance we degraded with the Fluent with the ice. That'll be the next video.